Here's an example. Our prediction here is that yoga decreases subjective stress. And if this was a proper study, we'd have to have operational definitions for these variables. So we'd have to define what we mean by yoga. It might be a particular kind of yoga. We'd have to specify how long people are doing it for, how many times per week, and over what time period, and so on. We'd also have to define subjective stress. We'd have to have a measurement of subjective stress, but I'm going to, just for the sake of brevity here, assume that we've got operational definitions, because what I want to focus on here is the research design of an experiment. So if you look in the pink box here, we take a group of people who are experiencing stress in their lives. They feel stressed, okay? And this might be, let's say it's 200 people. So we randomly divide the group into two groups, and there's no systematic differences between these groups. We just randomly take 100 of those people and put them into a yoga group, and we take the other 100 people and we put them into the non-yoga group, and then we go through the collection of the data. So in the yoga group, let's say that the people come to your yoga studio 3 times a week over a 3-month period, and they do yoga for an hour each time. Okay, so that's the experimental group. And let's say that in the non-yoga group, these people come to your yoga studio 3 times per week for an hour per time over a 3-month period, but they don't do yoga. They maybe just sit and relax, or sit and read a magazine, or sit and read about yoga, but they don't do yoga. Okay, so after the 3-month period, you then measure everybody's stress score. And if your hypothesis is supported, you should see lower stress scores in the yoga group than in the non-yoga group. And that essentially is the design of an experiment. So in an experiment, we have an independent variable, and the independent variable is the one that gets manipulated by the experimenter. So in the previous example, what was the independent variable? The independent variable there was yoga versus no yoga. The dependent variable is the outcome. It's what gets measured. So what was the dependent variable in the yoga study? It was the subjective stress score. We have a control condition, and sometimes it's called the control group, and the control group gets the placebo if it's a drug study, or no treatment. So in this case, the control group is the group that didn't do yoga. In the drug study, the control group is the one that gets the placebo. And essentially then what's being compared at the end of everything, you're comparing the results for the control group compared to the experimental group. And what you're looking for here are differences between these two groups that support your prediction. Now, if you think about it, not all variables can be manipulated by experimenters. There are things like age, sex, IQ, sexual orientation, and so on. These cannot be manipulated by researchers. You can't have people come into your study and say, okay, I'll assign you to be the males and you to be the females, or you to be the people with the high IQs and you to be the people with the low IQs. Subjects are already assigned to group. That's part of who they are. That's a quality of their person. So in this case, you can't randomly assign people to sex. You can't randomly assign people to be smarter or less smart. You can't randomly assign people to be gay or straight. And because of this, these types of variables are very difficult to study, because you can't, for example, if you're looking for sex differences in, let's say, I don't know, some ability like mathematical ability, which is something that's been often studied, you can't take someone who's 30, who's a man, and erase their experiences as a man and reassign them to be a woman. And because of that, it's very hard to separate the effects of biology and the effects of environment in those types of studies. So just so that you're aware, not all variables can be manipulated by experimenters, and it makes researching those types of things a lot trickier and much harder to interpret. You have to be more cautious in the interpretation of your results. So if, for example, you find that there's a difference in mathematical ability between men and women who are aged 30, you don't know, is it because of something biological? Is it that there's a difference in the male-female brain? Is that the reason? Is it a difference in experience? Do men and women have different experiences that give them benefits in math? And there are also even further interpretations that are possible. For example, perhaps the experiences that people have as children changes the way the brain is wired, or changes the way the brain is works in some way that's related to math. So you can see that it's much more difficult to interpret results for these types of variables. We've looked at some of the differences in research design. Let's turn now and look a little bit at how we evaluate the results of a piece of research in terms of some of the basic differences between descriptive and inferential statistics. Okay, descriptive statistics are procedures that essentially make it easier for you to summarize the findings that you have. So these are ways to organize and summarize results. And examples of descriptive statistics that you probably already know about are things like the mean, which is the average, standard deviation, which is a measure of the variability in a set of scores, the median, which is the middle score, the mode, which is the most frequently occurring score, and so on. And sometimes descriptive statistics are extremely useful because you have a large group of subjects and you can't kind of summarize them in any easy way without these types of numbers like the mean and the standard deviation. If you imagine trying to understand or trying to explain to somebody, have a group of 200 subjects, these are the scores. You need descriptive statistics to help you do that. Otherwise, trying to understand 200 scores is just too impossible and difficult. So take a look at this graphic, and it's just a very simple example of why descriptive statistics can be interesting and informative. So here, both of these graphs are have a mean of 5, so they have an average score of 5, and the score ranges between 0 and 10. And if you look up the left-hand side where it says frequency, how high the red dot is corresponds to how many times that number occurs. So if you look, for example, at the top graphic here, you can see that the mean is 5, and you can see that 4 people have a score of 5, and 2 people have a score of 4, 2 people have a score of 6, and 1 each has a score of 3 and 7. So there are no scores below 3, and there are no scores above 7. All right, and the mean is 5. Now, if you compare this with the graph below, you can see we have the same number of scores. We still have a mean that's 5, but now we only have 2 people with a score of 5, and then we have 1 person each with a score between 1 and 9. So we have 2 very different looking sets of data, but the mean is the same. Now, the statistic that will tell us a little bit about that spread of those red dots is the standard deviation. And standard deviation is a measure of how spread out the scores are around the mean. So the standard deviation here in the top graph would be lower than the standard deviation in the bottom. And so sometimes just understanding something like the mean and the standard deviation can, if you have a huge data set, tells you something interesting about how spread out the scores are around the mean. So this is just an example of descriptive statistics and how they're used. And so let's go back to our yoga example and look at how you might use descriptive statistics here. So let's say that when we had our stressed people at the beginning and before we actually did the study, we measured everybody's stress score and we got a mean of 65. And this is completely arbitrary. I've just made it up. but let's say that the mean is 65. Let's say it could vary between 0 and 100, and the mean is 65. So we have our yoga group and our non-yoga group. They go through the study, we collect the data, and at the end of it, we then again assess everybody's stress score. And now we find that the yoga group has a stress score with a mean of 45. All right, so it's gone down by 20 points. The mean has gone down by 20 points. The non-yoga group has also gone down. They've gone down by 10 points, so they're at 55. So now we have a rather interesting situation. We've shown that yoga does result in a drop in stress, but interestingly, so does this other thing that we did. All right, now what do we know about that? How do we interpret that difference between 45 and 55? Well, descriptive statistics don't allow us to go any further, really. We're just describing what we've got. And so to go any further than that, we actually need to use descriptive statistics. Sorry, we actually need to use inferential statistics. So